A lot of times we're going to study on two variables relationship, see if they are growing together, what's kind of a correlationship between them. So the most common used test is called the Pearsons uh, coefficient test, which is referring to Pearson R. The range is from -1 to 1. So basically, if the two variables are related closely to each other, if variable x growing, while variable y growing, so in same direction, that means the result of Pearson R will be 1, so they're growing in one direction. So if they're opposite, like one x is growing and y is decreasing, that means they're opposite, then the value is more close to -1. So if they don't really having any relationship between them, so the value, Pearson R's value will be more closely to 0. One thing we need to pay attention to is correlation does not imply causal relationship. What does that mean is there is one example from the book is about a set of data and showing income is correlated to low performance. So I guess the study was collecting data, a great set of data, and showing the income. When income is higher, and then the performance is lower. So that means they are opposite. Really, the income is the variable to really changing to making the performance low. So more study you will be do and to find out, okay, income is really related to age. When income's higher, that means the age is older. When older people have more income or more saving, probably relatively, and then the people's age is really the cause of the low performance on the computer. So there is hiding factors there. We cannot directly say, okay, income is opposite to the performance. So the more rich people will have low performance. That's not necessarily true. Regression also used for couple purpose of the relationship. Regression can investigate the relation between one dependent variable and multiple independent variable, and it can build a model and can do prediction. Different regression procedures also produce the simultaneous and the hierarchies. So far, what we talk about all the tests is a parametrics test, and for non-parametric test, which can be used when the error is not. So which means we assume that all the error is normally distributed. So what about if those errors are not distributed normally? Then we can use a non-parametrical testing. The distance between data also are not evenly distributed. So what we use is a chi-square test. Chi-square test again use analysis categorical data. Is discrete data. Assumption of the test is the data point need to be independent, and the sample size should not be too small. So we can do chi testing. And non-parametric tests, two group data in that situation, and for between group designs, we have MWU test and Wolf-Waltz run test. And for within groups, we have Watson's signed rank test. And for 3 or more group of data, then we have a coding test here. So that's kind of summarize all different kind of tests we can do for experimental data. And the next part, I'm going to talk about survey. We'll try to